Okay, so hello everyone. Well, in this video, I wanted to make an introduction into how we can start manipulating data for performing classification using the libraries from Python, in particular sklearn. And the purpose of these videos is that we can start working together into how we can start this journey on how we can learn to use Python to perform machine learning, not to train machine learning algorithms, and also to get familiar with the libraries that Python already has, not to perform these tasks. So the whole goal of these videos or presentations is that I wanted to introduce to you these topics, okay? And also I am learning myself, no? So in these videos also I want to learn how to explain all of these concepts to a broader audience. That's why many of these videos will be um, presenting in English, no? Or I will be speaking in English. I am not a native speaker of the English language. I come from another country, in particular Mexico, and I speak Spanish most of the time. So I want to use also these videos as an opportunity to start practicing the language. So, well, in this first video, I will be showing you some of the codes that you can use to start working um, with data sets using scikit-learn, pandas, and so on, how you can work a little bit with a data frame. And to do that, I will be using a Jupyter notebook. In particular, if you look at my window, you will see that I am using Visual Studio Code. So I installed the Jupyter extension in Visual Studio Code, but the reality is that you can also run these codes in Google Collaboratory. So you don't need to worry too much about the code. And also I will be sharing or I will placing in the description of this video the code that you need. Okay? So you want to follow up later into these codes. So in this first video, I will be showing you how we can import a particular data set that we can use for multi-class classification. It's called the MNIST dataset. This MNIST dataset is basically a dataset that we can use to perform or train algorithms with the purpose of generating a model that can serve for binary or multi-class classification, but the problem is focused on classifying digits, no? Like 0, 1, 2, 3, 4, and 5. In particular, we are using digits, or we are having images of digits like the 0, the 1, the 2, the 3, the 4, and 5. And we want to generate a model by using machine learning that can take that 0 and detect if it is a 0, a 1, a 2, and 3, a 4, because we have images of that. Now we have images of those digits, and we want to generate a mathematical model that classifies automatically the image of those digits. Okay? So here in this Jupyter notebook, what I am doing first is to import a library or a function from a library that is called scikit-learn. To do that, I am using this function or this command that is called from scikit-learn.datasets, and we are importing a function that is called import fetch underscore openml. You need to use this function, and well, here I am saving, I am generating a variable that I am calling MNIST that is equal to fetch underscore open model. And I am, well, the arguments of this function is the name of the dataset that I want. That in this case is the MNIST underscore 784. And I am selecting the version number 1. So we can run this code. And basically, we are getting a dictionary that contains the dataset that we want to use. Um, and it's taking a little bit of time because we are getting the dataset from OpenML. That is basically the repository in which this dataset is, well, is stored. And, well, this MNIST variable basically saving a dictionary in Python. And well, as you know, in Python, we have these dictionaries that have a key and a value. So here I am showing you, or I'm printing the keys of this dictionary that contains the data set. So the keys include the data, that is basically the pixels of the digits that we want to classify or process. We have also a key that is related to the target. It's basically the label of each of the digits that we have. Also, we have other like the frames, categories, feature names, and so on. But for this video, I want to focus only on how we can manipulate the data and also the target variable. So in order to get the variable from the data, well, I am taking again the dictionary and I am placing under brackets the key that in this case is data. And I am saving this data into a variable that I am labeled as X. And also I am doing the same for the target, and I am saving the information in a variable Y. The reason of this is that, well, remember that we are basically want to generate a model that relates the input, and in this case is X, that contains the digits, with a response, no? That is the target variable. That is basically the labels associated with these digits. That, well, since I have an image that contains the digit number 5, well, the target will have a label that will have the corresponding value of the digit that is also 5. Okay? But also remember that here we are dealing with an image and we want to map this image value into a numerical value, no? That in this case is the digit value. Okay? So that is why I am using this X and Y notation for my variables, because essentially what we are doing is to map this X input with the Y input. Also, another thing that I wanted to mention is that um, these X and Y variables, as I mentioned before, are taken from a dictionary, but this dictionary can contain different types of variables in Python. Here we can see that this X variable, essentially, I will add another code here. We can type and then write X, and then we can press Control and Enter, and you can see here that we are working with a data frame. Okay, so yeah, the original variable is a dictionary, but once we have extracted the information that is contained in data, we are working with a data frame. And the usefulness of that is that we can also use some of the pandas methods in order to compute certain information from these data sets. Also, we can do a similar thing for the white variable. We can control and enter, and you can see that here Python is telling us that we are working with a panda series. So again, we can apply some of the methods that are available in pandas, no, either in the data frames or panda series, perform certain computations about the distribution or the structure of this data. So that's why when you can see here that I am printing here as information the shape of the data and also the shape of the target data. So when I run this, you can see that I am printing the shape of the inputs. Here you have two values. That means that we have a structure that has 7,000 rows and 784 columns. Okay, in this case, the rows represent samples from the dataset. That means digits or different types of digits, and the 784 columns represent the pixels of each of the images or samples. That means that these columns are basically the values of the pixels. We also call them features. No, they are features from the input image, and also we have the shape of the output that in this case is 700 again. That is also associated with the number of samples that we have. Notice that, well, according to the pandas notation, we don't have a value here for the columns. This means that we are working, at least for the white variable, this variable has a shape of 7,000 rows and one column. That's why, well, based on the pandas notation, we don't have this value in this position. Also, we can, for example, use another method that is called dot head. And this method can help us to visualize the first rows in the data set. So if we can run this, you can see that we have here the first 4 rows starting from position 0. And in each of the columns, we are basically having information about the pixels. Pixel 1, 2, 3, 4, and 5. That are basically the pixels that, well, are basically the number of columns that we discussed previously. In other words, these 804 columns represents the features or the values of each pixel in the image. Also, we can compute like a summary of statistics of the dataset using this method that is called .describe. And this method is also useful because we can summarize the dataset. At least since here we are working with images, you will see that this method is not too descriptive. But this is another type of operation that you can perform on your dataset. This is mostly useful when you are working with structured data, like, for example, working with the age, the body mass index, the heart rate, or the gender of some population. Okay? And you can see that we can see that this describe method computes the count. That means how many samples we have, the mean, the standard deviation, the mean value, the 25 percentile, the 50 percentile, and so on, for each of the features or each of the pixels that we have. And also we can plot or see a visualization of this data set. For example, we can use the matplotlib library, in particular the part of pgplot. So to do that, we can use this command that is called import matplotlib.pgplot as plt. We are storing in this variable that is called some digit one of the samples from the data set. So that is why we are using this x.ilog. Ilog, what it's basically doing is to extract indexes from the data frame that we're using. So in this case, I am telling Python that I want to extract the index number 0 from the data frame x. And I'm converting this data or these pixels taken from the data frame into a numpy array. That's why I'm using this method that is called .to_numpy in order to compute information from the data frame into a numpy array. And that is useful because I can reshape the data of the image into a 24 by 24 pixel image. And then I can use this reshape image and plot it by using the plt.imshow function in the matplotlib library. And also I can tell that the color map of this image will be binary. And well, here I am also using these commands to plot the digit, and you can see that we have the following result. Also, we can do a similar thing for plotting many types of digits. So to do that, you can see here that we have a for loop in Python that is basically telling Python, okay, you need to iterate the code that is inside this for loop in the following way. We start with a variable I that goes from the range from 0, well, it has a range of 10. That means that the variable I will take values from 0 to 10 minus 1. Okay. So we are starting from index number 0, and then we finish to index number 9. And from 0 to 9, we have 10 values. No? So basically, this function is iterating the variable I from 0 to 1. Then we are plotting, well, we are generating a subplot that has the following grid. We will have 2 columns and 2 rows and 5 columns. And in this in each of these positions, we are plotting a digit that taken from the data set. So this, we are taking the image at position I, and then we are plotting the information according to the grid of the subplot that we generate previously. And well, we are using these functions in order to plot the following information. And here you can see that here we have 5, 4, 5, 0, 4, 1, 9, and so on. And also this is useful because we can visualize a little bit more the information that we have already stored in the data set. Another thing that I wanted to point out is that it's also convenient to explore the type that we have in the target. So you can see here that at position 0, we have a target equal to 5 that corresponds with the first position in the data that is stored in the variable x. But you can see here that we have a string value. You can see here that because we have these quotes that um, that are placed in this target. No, we have quotes that are surrounding the number 5. So the problem is that we cannot train machine learning models if we have a string value. No, so in order to avoid that, we need to convert the values in y into integers. So to do that, we can use this following method that is called y equal dot as type int. And basically this command is converting the string information into integers. So what I'm doing here is to change the values of the y variable into integers, and then I'm printing the position number 0. And this is the number 5. And well, as you can see, well, this is a little bit of data manipulation. We can corroborate that this function has already converted all of the integers into integers by running this code again. And here you can see that we have a 3 and so on. No, and this is telling us that, well, we are now working with integer values in the target variable. And well, typically when we are working with machine learning classifiers, you need to divide the data set into a train and validation and test sets. So for that purpose, and to make like the overview of how you can train this classifier using the MNIST dataset, what I am doing here is that I am generating slices from the rows in the variable x. And by doing that, I am separating the dataset into a train and test sets. And here I am using these commands to show you the partitions. No, in this case, I am using as a validation set from position number 0 to position 6000. And I am using as a test set from position 6000 until the end of the data set. Okay. So here you can see that this is the resultant shapes for the train and test data sets. And well, first I wanted to make a binary classifier. So to do that, I am creating a new variable that will create or will place a 0 or a 1 when we have a target variable equal to 5. This means that that we want to generate this classifier that detects only the number 5 in the dataset. So this command or this instruction is basically telling, okay, if the train and test datasets are equal to 5, in particular the target variables, well, we can assign a 1 to to another vector that is called gtrain5 and gtest5. And if in the other way, if we have another value different from 5, we assign a 0 to that. And well, we can run this command to perform that operation. And let's say that we want to train a binary classifier, no? Basically, a model that detects number 5 and that, well, and also detects any other number. But in particular, we want to pay attention that we want to always detect that number 5. and we don't care about which digit is the other samples that are different from the digit number 5. So, well, to do that, we can train a simple classifier using a stochastic gradient descent classifier that is available in the sklearn library, in particular in the linear models. And well, to do that, well, you need to import the stochastic gradient descent classifier. That is the meaning of SGD, refers to stochastic gradient descent. But here we are working with linear classifiers like supervector machines or logistic regression. By default, the stochastic gradient descent classifier works as a linear support vector machine. We will discuss later on what is a support vector machine in later videos. And also, well, first, once you import this stochastic gradient descent classifier, you need to define the object. And once you have defined the object that will contain the model, you can feed it. And in order to feed the classifier, you need to use this method called .fit. And then you need to use as the first argument the x variable for the training set. And you need to use the y variable for the valid for the train set also. And you can feed the model. So I will run it here in my Jupyter notebook. And you can see that since it is performing an estimation of certain parameters, the training will take a while. And well, I think that, well, it will take a while because it's basically performing an optimization process using stochastic gradient descent. Also, you can see that since we are working with an stochastic method, there is a certain degree of certainty in how the method is initialized when we want to estimate the parameters of the model. So in order to ensure reproducibility, we are setting this random state equal to 42. And basically this setting this command allows us to generate reproducible results. And this is the way in which you can basically train a very simple classifier, you know? In sklearn, we have available many type of classifiers like linear discriminant analysis, stochastic gradient descent, and so on. But we will explore all of those classifiers later. First, I want to introduce you to a very navy classifier. And in fact, it's already been trained. It takes like around 1 minute. And well, after that, we can take, for example, the digit that we extracted previously. As you remember, we defined as some digit the sample that is at position number 0 in the data set. So we will be using this sample as an input into the model. We can perform a prediction with our already trained model using this method called .predict. And we place here under brackets the digit that we extracted previously. And well, you can see that we get a true as a result. That is expected since we know that at position 0, we have this digit number 5. So we can say, at least by making this very simple the simple model, that the model is working. No, and we will see later that there are certain details related to this classifier that you need to take into account. But well, I will discuss that in a later video. As it's only an overview how you can process the information. But in a second video, I will deepen into what is this classifier doing, and in particular, I want to focus in how you can perform performance metrics, no? How you can evaluate the performance of your model, okay? And we will discuss things like the confusion metrics, the accuracy, the precision, and the recall. And later, I will make a video explain other type of metrics that we can use in classification, like the receiver operating characteristic curve, okay? So I hope you like this video, and see you later.